Hi guys. So today we're gonna look at a type of configuration that could be beneficial to find an equivalent resistance to a circuit like this. So today we'll be focusing on delta to Y transformations. If you have a delta network like this where it has resistances in this kind of format, we're able to convert these resistances into a resistance network, RA, RB, and RC, which is the Y network, by using these different formulas here. So these formulas are only specifically converting from a delta to Y network. This circuit right here doesn't look like it's a delta network, but I'll show you in a second that it actually is. So if we're able to redraw the circuit, we can see that it's actually two delta networks, like this. Where we have the 18 ohm resistors top, 12 ohms, 6 ohms. So we can see it looks like this. These two nodes are just connected by a point, and these two bottom nodes are connected by a point too. So we want to find what the current is at the bottom line right here. So what we want to do is we want to actually convert this top delta network into the Y network in order to simplify the circuit. So for this circuit, we would have the top delta network where it's 18 ohms on top, and then we would have the 12 ohm resistor, 6 ohm resistor, the current that we're trying to solve for, and the current source, which produces 3 amps. So we want to convert this to the Y network. We can do this by using these formulas: RA, RB, and RC. Now, since the top delta network all has the same resistance of 18 ohms, RA, RB, and RC will be the same. So, for example, we could say RA equals RB equals RC is equal to R1 times R2, which is 18 times 18, plus the total resistance, R1 plus R2 plus R3, which is 18 plus 18 plus 18. This gives us that RA, RB, and RC is equal to 324 divided by 54 equals 6. So we could see that RA, RB, and RC will equal to 6 ohms. And we could redraw this circuit by using the Y network. So if we use the Y network, we have something where it's 6 ohms, 6 ohms, 6 ohms. And then we have the bottom delta network, which is just 12 ohms and 6 ohms. Then we have the current source producing 3 amps. And it would look like this. Now we can see that this 6 ohms and this 12 ohms are in series, and these 6 and 6 are in series. So we can simplify the circuit even more. So since 6 and 12 are in series, we can say 6 plus 12 equals 18, and 6 plus 6 equals 12. So we can redraw the circuit again. We have 6 ohms, we have 18 ohms and 12 ohms, and the current source. So we see 18 and 12 are actually in parallel, so we could further the circuit even more. 18 is in parallel with 12. That gives us 7.2 ohms. And we can redraw the circuit again. Now we have these two are in series, so we could actually find the total voltage drop across these since they're in series. But let's focus on the voltage drop of this 7.2 ohm resistor. The reason why we want to focus on this is because we want to go back and try to find the current that's attaching to the bottom delta network, which is I. So let's go ahead and do that. So the voltage drop across the 7.2 resistor is just V is equal to the current going in, which is 3 amps, times the resistance, 7.2, and this gives us 21.6 volts. So that means the voltage drop across the 18 ohm resistor and the 12 ohm resistor is 21.6 volts. So if we look back over here, we could say, okay, well, this current that's going to the 6 ohm resistor is 3 amps. This current splits up into I1 and I2. So to find the current I1, what we want to do is we want to say I1 is equal to the voltage drop, which is 21.6, divided by the total resistance, which is 18 ohms. And that gives us 1.2 amps. So if we look at this node over here, we see that I1 is going in and I is going in as well. So by KCL, we could say everything going in is just I1 plus I equals 0. Now I1 is equal to 1.2, so that means that I is equal to negative 1.2 amps. So this is just a simple circuit converting from the delta network into the Y network to find the equivalent resistance and to simplify the circuit even further to find the current at the bottom delta Y network. Awesome, thank you.